Extending the effective context window of LLMs is one thing. Actually making the model use that window is another. There is a persistent gap between the maximum tokens a model can technically accept and its actual effective capacity. Enter OPSDL, on-policy self-distillation for long-context language models. Most current methods rely on high-quality human data or sparse, sequence-level rewards, like DPO, which can be unstable and inefficient. OPSDL takes a different approach. It leverages a fundamental asymmetry. A model is almost always better at answering a query when given a concise, relevant short context than when that same information is buried in a massive document. OPSDL uses the model's own short context performance as a self-teacher to supervise its long context behavior. Here is the technical breakdown. The researchers create triplets consisting of a long context, a corresponding short context extract, and a query. The model generates a response based on the full long context. Simultaneously, the same model, acting as the teacher, generates a distribution based on the short context. Instead of a coarse reward, OPSDL uses a pointwise reverse KL divergence to calculate a token-level advantage. If the short context teacher assigns a higher probability to a token than the long context student, it signals that the student is underweighting key evidence. If the student is more confident than the teacher, it's likely a hallucination induced by the noise of the long context. By optimizing via policy gradient on these dense, token-level signals, the model learns to ignore the noise and stay faithful to the evidence. The results are impressive. Across Qwen 2.5 models from 7B to 32B, OPSDL consistently outperformed standard SFT and LongPo. On the ruler benchmark, it drastically closed the gap with models specifically pre-trained for million-token contexts, all while preserving general short context capabilities. It's a scalable, stable, and model-agnostic way to unlock true long-context reasoning.